In this experiment, the entire idea was to basically test the effects of various amounts of water in a cylinder-shaped bottle, some of it having air and different amounts of water. And our goal was to essentially to see if a taller bottle with more height would actually make a louder frequency, and ultimately proving if adding more amounts of water would decrease or increase the frequency. Our hypothesis stated that if we conduct an experiment regarding the size of the glass to the volume and the effects water has on it, then the largest glass with the most amount of water would have the largest frequency. To start this experiment, I want to go over the background information. All of this information is derived from the 16.1 synthesis and figure 16.19 part C from the book. For starters, I want to go over the basics of what is a wave. A wave consists of nodes and antinodes, where the nodes are where the waves meet and the antinodes are the peaks and low points areas of the wave. The open closed tube has a node at one end and an antinode on the other. Only odd numbers antinodes are possible. And to determine this mode number, one could simply imagine doubling the length at the closed end and count the antinodes. What the important information in this is that the fundamental frequency of an open-closed tube is half that of an open-open or a closed-closed tube, assuming they had the exact same length. We use 4 times the length instead of 2 times the length in an open-closed tube, which is why the frequency is half that of other tubes. Now that the background information is settled, I want to go over what the variables are. The dependent variable is the frequency of each bottle, and the independent variable is the glass we used, which did not change throughout the entire experiment. The way we measured it is through the amount of air in the glass, measured in inches, which was compared to the amount of water it has. And with this, the general idea was seeing what the effects of water would have on this. The total size of the bottle glass was 9.8 inches. We did 3 trials in this. The first trial had 7.2 inches of air in the Coke bottle and 2.6 inches of water. The second trial had 4.9 inches of air and 4.9 inches of water. The third trial had 2.4 inches of air and 7.4 inches of water. So essentially, as you go up in trials, we are adding more and more water. From here, we blew into the glass to produce a vibration, which is an oscillation down the side of the solid glass and in the water to produce the sound that we hear. To recap, according to our hypothesis, the third trial with 7.4 inches of water should have the greatest frequency. With this hypothesis in mind, we got exactly that. On the screen you will see our data laid out. Trial 1 ended up having 250 Hz of frequency. Trial 2 ended up having 314 Hz of frequency. And Trial 3 had 1,259 Hz of frequency. Meaning that, as expected, the bottle with the most amount of water and the least amount of air produced the highest frequency. Now, to get away from the numbers, I want to go shortly over what this information means and attempt to conclude this. According to our information, it seems that the largest bottle with the most amount of water actually did produce the loudest frequency. Not only that, adding more amounts of water significantly raised the frequency on most of the trials. From this information, we can derive that water does increase frequency in a bottle. And that was our experiment. Thank you so much for listening, and stay classy.